Hello, ladies and gentlemen, my name is Kurt, and welcome back to Space Engine, the amazing and very beautiful universe exploration, education, 3D simulation, and other sort of ations, has had a recent update. Actually, a little bit ago, May 1st, they released version 0.9.7, bunch of updates. We are here right now looking from an exterior view of the Milky Way system. We have our little pointer on Earth, so let's go there. And I'd like to give a little bit of a update. There have been a lot of updates and additions to the game, but a few things that are the most noticeable, and then as we normally come back to Space Engine for some astronomy and space news. But let's go to Earth, why don't we? I'm gonna press G, and that did nothing. Oh yeah, okay, G, yeah, I'm like, did they change all the shortcuts? No, G is to travel to your destination, or your target, I guess. But for those new subscribers out there who might not have seen all my old space astronomy education type videos before, Space Engine right here, as you could tell, is a free program. Download link is in the video description. Whoop, we are looking at the planet upside down. Let me change that. Where you can explore not only the solar system, as you can see right here, and all the planets and moons, but you can go out into all these stars and nebula and different galaxies, and it will, once you're out into the area where current science has not explored or identified objects, it will actually start to procedurally generate, as in invent, based on actual estimations of what kinds of stars, and then if those stars have planets, and what kind of planets those would be, etc., etc. So it's really cool just to get lost and explore. Making a bunch of updates lately. It's very resource intensive. You can't really have a slow or old machine and expect to run this at any sort of, run this at any sort of reasonable level. So you might have to have a little bit of definitely a dedicated graphics card, but definitely, not running on your old Windows XP laptop. You're not going to have a good time. But anyway, here we are around Earth, and right away you can see one of the additions that they've made up on the top. Hopefully YouTube is quality enough to be able to be showing you that we have atmospheric effects like the Aurora Borealis right here. And this is odd timing, is that there was actually recently a few very strong events from the sun that have caused a kind of an outbreak, a solar geomagnetic storm on Earth. And if those of you who have been blinded by the sun, no, those of you who have live on the far northern or southern parts of the planet might have been treated to a sky show, if you will. So it's really cool that they added this. Let me get in real close. Whoa, through the planet. Let's slow down a little bit. Yeah, they're dynamic. They move very slowly. I'm not sure if you can see. So a lot of planets, not only on Earth too. If I went out to Saturn or Jupiter, they have Aurora as well. Although I believe they might be called something else because they're on a different planet. But yeah, very cool. Of course, we have Earth, and you can also maybe notice off in the distance another addition to the game, something that was missing. For quite a while, was comets. And there we have Comet PANSTARRS. That was pure accident to have this in the field of view. The problem with comets is that since they're not solid objects like planets and moons, they're take a little bit more power and some mathematics, I guess, to render the tails and stuff. So we have PANSTARRS, was the comet that recently passed around the sun, and if you were following me for a while, I've tried to mention that. It's very difficult to see. It was very close to the sun for us northern hemisphere sky watchers. I never had a chance to, unfortunately, see it. You had to have been very lucky and have a very low and clear western horizon to see it, but it's on its way. It's on its way back out into the far reaches of the solar system from whence it came. But in the latest version of Space Engine, we can get a close-up view. We can visit Comet PANSTARRS where it is. We can see that a comet The nucleus is actually made up of a nice rocky, icy core. And also one of the things that they added to Space Engine is the material from comets actually evaporates. So if I were to fast forward time, as you can in Space Engine, or reverse time, the material, the size of the comet will actually change, as if in the real universe, the solar wind actually blows away and melts and ejects all the dust and ice and stuff like that. So that's a really cool thing. So yeah, from the nucleus you can't really see much, but from out here, hopefully you can see Comet PANSTARRS. Most comets have two tails. There's a tail of material coming from the direction it's actually traveling, and then a secondary tail from the direction that it's actually being affected by the solar wind. I really hope that this is clear enough. It's very faint here, and the solar system, or not the solar system, the Milky Way in the background is actually a little bit artificially brightened so that it brings out the detail in the game. But I think if I zoom out far enough, that's probably Mars. Let's turn on orbits. Here's the orbit of PANSTARRS. As you can see, we have actually no idea where it came from. So it's a very, very large orbit, and once it leaves, I don't believe it's going to be returning for at least another 100,000, a couple million years, maybe. It's hard to calculate. And of course, coming in, whoa, so close to the sun, its orbit is a little bit affected. So a once-in-a-lifetime event. We could also look for, I'm gonna press F3 to bring up the search window. Comet ISON, ISON, is the one I've mentioned also. There's ISON, even more of an eccentric orbit. Is currently on its way. Oh, you know what? I think I might... Yeah, I'm actually looking at December 16th, 2013. Let me fix that by going to... I believe this is set current time. Alright, yeah, now we are properly on the 20th of May, 2013. Oops! See, with the time travel, but you can see Comet ISON has actually recently gotten closer than the orbit of Jupiter, which is what that is. And it's due to arrive after the summer, and then it's estimated that this one will be, if it survives, as you can see, it gets really close to the sun. It's known as a sun grazer comet. If it survives and all of the material isn't destroyed or it doesn't break apart when it has its close encounter with the sun, it's estimated that it might be the brightest comet ever to be observed in the history of all mankind. Like, brighter than possibly the moon, possibly visible in the daytime. That's December 2013. There are a lot of things that have to go right for that to happen, and even Comet PANSTARRS, the one I just showed you, was estimated to be so bright and so visible for many, many nights, but it turned out to be a little bit of a letdown from the sake of being visible via the naked eye. But as you can see out here outside of Jupiter, Comet ISON can't see that much of a tail. It does have a little bit of a tail now. There are Hubble Space Telescope pictures that are bringing back. It is starting to pick up as it gets closer and closer to the sun. More material. Whoa, we're inside. We're inside Comet ISON. Sorry. It is starting to pick up a little bit more of a tail, but right now in the software it hasn't achieved a tail yet. But yeah, that I guess is a really cool representation of where the comets come from. Way out here, there's Ceres and Pluto and all the other pseudo, what are they called? Minor planets, I guess you can call them. Minor planets? I don't know. Are out there. So it's going to come for a very close encounter with the sun. Let us go, just to prove, let's go to Saturn. Okay, go to, please. Oh, I did not select it. Aha. Go to G. We're going to go to Saturn, and just to show you with the... they've improved other things with the planetary rings, but also I believe we should be able to get an Aurora. Let's turn off the orbits. Saturn has a lot of moons. Should be some Aurora on Saturn as well. Maybe not. It might be a little bit too dim for Saturn. The rings might be. Oh yeah, there are. Again, this I doubt you'll be able to see. I don't even think you can see my cursor. But there's very faint Aurora just on the limb there around Saturn. But they have improved the ring light. Oh, we can recreate. Wow, like to great accuracy, we can recreate the picture that I'm sure a lot of you have seen from Cassini as it passed behind Saturn and the sun was eclipsed by the planet. It took a picture and you're able to see all the way out, and it discovered even further distant rings, the F rings and stuff like that are way beyond even just the rings that you could plainly see if you look at it like a telescope like this. Very cool. Well done, space engine. Well done. Alright, so we got that. Another bit of news that I have is regarding... Let's go back to Earth. Welcome to Earth! Reference! Going back to Earth. Oh, I gotta go, actually. We're gonna pass through the rings of Saturn, and to Earth. Lens flare. It's like we're J.J. Abrams. Going back to Earth, there is some news with the Kepler Space Telescope. Some concerning news. The Kepler Space Telescope is the telescope that looks for planets, exoplanets. It is the one that is actually... It orbits quite a distance away from the planet to get, obviously, less interference from the planet Earth, the Earth shine, this light, also the moon. I wonder, how do I think there's a way to turn on the constellations. Come on, guy, where are you at? No. Yeah, let's look at our options here. Maybe I don't have constellations. I thought that there were. That's the grid. Vectors, Victor. Well, that's unfortunate. I wish I could identify things with this many stars in the sky. We have... Hold on, there's obviously the oh, hello, that's the sun. There's Andromeda in the distance. There's the Pleiades. I'm looking for Cygnus. Anyway, the Kepler Space Telescope literally points at the same point in the sky in Cygnus and looks at the same 150,000 some odd stars and just observes them all at the same time. And it looks for patterns in those stars that would make it dim and then brighten again, which would indicate a planetary transit, a planet passing in front of the light of the sun, or the star, anyway, we're looking at. And then you can estimate the size, the orbit, the speed, the velocity, the whatever of a planet that might be causing that very sequence of dimming and brightening of the stars. Unfortunately, on May 15th, it went into safe mode, the satellite, because one of its reaction wheels has failed, which actually is the second reaction wheel. It has 4 reaction wheels. These are basically, I guess you could say in simplistic terms, like gimbals. You know, in Kerbal Space Program, when you're flying a spacecraft and you can turn the spacecraft without having any thrusters or RCS or anything like that. You got to pretend that there's little reaction wheels, little gimbals that actually cause torquing, that cause that movement. And that is how the Kepler Space Telescope can remain pointed and aimed at a very specific point and be very accurate, is with these reaction wheels. It requires 3 reaction wheels for that accurate pointing, with one that failed in 2012 and then one that failed earlier this month. It's now only down to 2, and it can't be pointed properly, which is a problem. It can possibly, they're looking at options, it can possibly be pointed with its thrusters, like RCS thrusters. Obviously that's much more crude and not as accurate, and eventually you'll run out of thruster fuel. And they're looking to see if they can go back and restart the reaction wheel that failed in 2012. So it's not, there's a lot of these headlines that say the Kepler Space Telescope is dead. I don't believe anybody at NASA or anybody involved in the project has said that the Kepler space mission is over and done with. They haven't just thrown up their arms and said phooey to it. They're looking at solutions. But even if it is, say, they can't fix it, and the mission without this accurate pointing, they obviously can't look at stars steady enough in order to get proper measurements. The Kepler Space Telescope has long surpassed its expected mission schedule and was actually extended once again in 2012, because you have a working space telescope up there, might as well keep using it. So we've certainly gotten very good use out of it. And segue, one of the more recent news is that it was discovered with data from Kepler. Kepler 62 is the name of the star. When you ever have a B, C, D, E, F, or any letters beyond it, that's the letters of a planet that has been discovered. So I am going to select Kepler 62, the star, center it. Alright, yeah, that makes sense. Where is Cygnus? Oh gosh, there's like too many stars. Anyway, let's just say Kepler points at this little pocket of the sky at all times. Around Kepler 62, it discovered 2 Earth-sized planets that are orbiting the star within its habitable zone. The habitable zone is the space, the distance away from the star that would allow liquid water to exist. It's worth mentioning that both Venus and Mars are within our star's habitable zone, but they obviously aren't habitable, so there's a lot more fine-tuning that needs to come down from that. But since we're here in Space Engine and we can travel anywhere in the universe, let's travel to Kepler 62 and take a look at its possible Earth-like planets. Warp speed, Spock, Captain. Wait, Spock was not the pilot. I apologize, I am not a Star Trek fan, but I do know that much because I'm sure I have been berated in the past for making such a mistake. But over to Kepler 62, the star we're looking at right now, and then I'm sure we'll see the planets. Kepler 62, the sun, or the star rather, is a little bit smaller than our own sun, a little bit cooler, so the planets actually can be a little bit closer, but be within that habitable zone, and already we can see a bunch of planets. Let's turn on orbits. Space Engine has either taken information from Kepler, actual scientific information, and they've coded these planets in here to accommodate for that, or it has procedurally generated these. But at least if we press, what do we press? F2? Yeah, if you press F2 while you have a star selected, you can look at its planets, its satellites. There's 62b, C, D, and then the ones we are concerned about that are actual planets that have been discovered are E and F. E is a little bit closer. It's, I'm taking, let me see here. Some of this, oh, actually this is right here, diameter. If you look on the left here, class, distance, diameter. This is accurate information, taken from an article I read that Kepler 62e is actually 1.6 times the diameter of Earth. I don't believe they know the mass yet. That could mean a lot of things, but it's 1.6 the diameter of Earth, and its year is actually 122 Earth years, or Earth days, excuse me. So it travels around its parent star once every 122 Earth days. Kepler 62f, is 1.4 times Earth's size, diameter, and its year, being orbiting further out, is 267 days. Sounds a lot like Earth, don't you think? So here in Space Engine, it has rendered these planets as warm oceanas. So Space Engine has said, even though we don't have this information about what the surface looks like, about whether or not there is even any sort of water or liquid water on these planets, Space Engine has taken the leap and said, sure, since there can be, let's make it interesting, and let's give these planets, this pretty much is an ocean planet. Space Engine has made it. There doesn't need to be land for there to be the potential of life, since life on Earth first came to be under the waters. It has also given, I don't think, no, it hasn't given this any stars, or, moons. but it has given it some Aurora, so Space Engine is saying that this planet has a magnetic field, perhaps protecting it from the winds of its star. Very cool. Kepler 62f. Let's go to E. E also doesn't... Whoa! Zoom in. E doesn't appear to have any moons either, but let's go to E to see what E is all about. E is also a hot oceania, they're saying. Let's go... Oh, being a little bit closer. That was a very cool kind of spiral thing going on there. Must be from facing the sun. Or the star, rather. I should stop calling it the sun. This parent star, very cool. So yeah, these are some of the things that you can do in Space Engine, is actually hear about headlines. This came out last month, April 18th is when this news was released. News was released that they've taken some of the data from the Kepler Space Telescope and actually said, yeah, these two planets that they've discovered are definitely within the habitable zone and definitely within a few, within a few percentages of about the size of Earth. So it's very cool. And then this is what Space Engine has just basically estimated, that if these planets exist and say they have liquid water, perhaps they're fully covered in liquid water. Very cool stuff indeed. And then there are additional planets around Kepler 62 which are much closer and far too warm for liquid water. So there's a scorched desert. A lot of the lens flare and lighting effects have been improved in Space Engine as well. Very, very impressive. Most impressive. So yeah, cool stuff, huh? Cool stuff indeed. But yeah, that I think wraps up really what I wanted to say about the updates to Space Engine. Like I said, there's a link in the doobly-doo for your own download needs. Like I said, try to have a little bit of a powerful computer if you want to get this type of stuff. I'm running the basic unmodified installation of Space Engine. There are now modding APIs. You can download different... Some users are making higher res textures for planets and moons and things like that, and bump maps, and eventually perhaps even... Wow, that would be one hell of a sunset right there. Very close to the star indeed. But one of the things that they mentioned in addition to comets is that evaporating planets. So I'm guessing planets that are too close to their parent star are evaporating. I haven't been able to find any of those just yet in Space Engine, so download it for yourself and check it out. Indeed. So from, say, the surface of Kepler 62f, a potential planet within the star's habitable zone. I'm going to thank you once again for watching. And let's, for the heck of it, let's search for Earth and see what Earth might look like from this planet. Looks like nothing at all. So yeah, thanks again for watching. My name is Kurt, this is Space Engine, and I will see you next time.